Alrighty guys, you probably saw I posted a little mini rampage about the grades. As I look at it, the thing that's probably dragging people down the most are the quizzes. So I put due dates on the quizzes because without due dates, they don't show up on the upcoming events over here, and I guess people weren't looking, weren't remembering that they needed to do them. The quizzes aren't too difficult, and if you don't do a great job, you can take them again, so your grade ought to get real good there. So basically, what I want to see is like the green bars, the B's and C's, and the DF bars swap, right? I'd rather give out huge numbers of A's and B's, and no F's and D's. So I think if we get to work, the second unit can be better than the first. Also, taking the exam will raise your quiz average up, but just because it's worth more than the quizzes, as long as you do well on the exam. But still, get the quizzes done. Almost free points, right? Same for the lectures. All you have to do is watch the lectures. If you don't feel like typing along with them, you just upload the little form that I posted, and you list a few things that you learned. Now, don't just upload a note saying, yeah, it was cool. You got to put a couple things in it that you learned from the lecture. Otherwise, I think that, you just muted it and listen to Lady Gaga or something like that. So anyways, let's get the grades up. I really want to see them get up. If you're behind on something, let me know, right? Some grades, some assignments have been coming in very late. The homework I'm not cutting off after 9 days like I did the in-class lectures. But, if you told me why, hey, I got to go to Washington, D.C. for my mom's funeral or whatever, I'm going to be out for a week. Okay, yeah, sure. Just let me know this stuff. If you're not letting me know this stuff, then I'm just assuming you're not doing it. Alrighty, so let's see. Important topics. Here's one I want to mention first. If you copy code off the internet that you find, I'll probably be able to tell just because it looks different than what I teach you, and it's probably using functions. So what happens is if it looks somewhat strange, I Google it up, and I probably find where you got it from. And, that may upset me a great deal. I may treat it as academic dishonesty. So, especially now that you've been warned a second time. For example, if I Google up factorial Python, alrighty. First result. All right, that looks pretty cool. Now, that one doesn't look as unique as the one that I saw, right? But so I might not have been able to tell that one, except for the fact that for some reason, somebody hard-coded in 23. And look for another one. Here, this writes a factorial function. It writes a recursive. It uses what's known as a recursive function. We absolutely have not talked about recursive functions. Maybe you know how to write for recursive functions. That'd be cool. I would look at it and I would ask you if you wrote it yourself if I couldn't find an identical version of it out on the internet. Anyways, what you do is you Google something up and then you make it your own. You rewrite it, right? Just like you wouldn't copy stuff out of Wikipedia and paste it into a paper, right? You'd make it your own. So even, most professors won't, let you use Wikipedia as a source anyways, but you get the idea. So I haven't, brought anybody's grade down to 0 yet because of that, but now that it's been mentioned again, please pay attention to that. All right, remind me to talk about global variables. Yeah, sure, I can do that. Don't use eval to process user input. Eval is really cool, really awesome, and really dangerous. Let me show you what it does. You don't have to type this in unless you just wanna. Eval is dangerous. So here's an example. Say I do this. X is equal to 10 minus 7. And I do an eval here. I have no idea what lecture we're on. I guess O, element O. All right, so now I'm going to print out X. And at first this made it look like really cool. And in fact, eval is really cool. It took this string and it ran it as though it were part of the program. It becomes part of the program itself. And then it returned whatever was in the string. You notice it converted it to an int even, right? And so that's what the student who was using eval was using it for is, they had an input statement like this, input, give me number. And they were treating it like, it was a float or an int function. Great, it works. Works for that purpose. Now I'm going to mess with this just a little bit. Yeah, but okay, so I'm going to define a function called fun. And all it does is print, this is fun. And now I'm going to run it. I'm going to ask for some user input. S is equal to input, type something. So we're going to store the result of whatever the user types there, and then we're going to evaluate it as though it is Python code in our program. We're letting the user effectively modify our code. Type something. Okay. I'm going to type in fun. It called the fun function. Right? They typed in something, and then it executed this code. Even though if you look at it, you don't see any way for it to be executing that code. But it is. All right, let's mess with that a little bit further. Type something. Okay, open eval.txt, write. Alrighty, what did it do? If we go and look, I believe it has actually opened a file. It has written to your operating system. Let's make sure that's the case. I could be lying. I found some examples. I made some examples. Well, and I can just look at my notes if I don't. There it is, right? So if there already was a file by that name, that would have deleted it. Right? Here's a really cool thing called lectureknotes.txt. Right? So I'm going to erase this file by running that program and letting it eval something. Type something. Okay. Open that file name for writing. It will erase that file. If I go back out and look, set it for text files. That file has been wiped out, right? It's 0 bytes. So eval is really cool, but you have to validate what it is before you call it, right? We have to check what this is before we evaluate it. And there are worse examples. There's one that would delete, every file in the directory. And I'm not going to show you all that. You can Google it up if you want. If you do import OS up at the top, you get the operating system functions built in, and then you start calling those operating system functions inside of eval. Because you can define multiple lines of code on one line of code. We could have actually multiple lines of code. And so if they typed in multiple lines of code there. So I kind of want y'all to know what eval does, and I kind of really want y'all not to do it. And I'm going to comment this out temporarily, And then if I do this, oh, come on. You see what it does. Whoops, I forgot the parentheses there. It executes the fun function. It just runs up there and executes it. If we asked the user for some input and they typed in fun parentheses in parentheses, it would run that function. That's what eval does. It takes a string and it executes it as Python code. Whatever you wanted to put in there, a print statement, we could do that. I'm going to change this back to being S. Okay, enter something. Okay, print whatever dude, and it prints whatever dude, right? But if there were some important variables, right, like password, you know, password equals, you know, goofy. And so then we run it, and I type in print parentheses password. Neat, I just found out what the password is, right? So you can display the value of any variable or whatever if it's just calling eval. All right, that's about enough of that. I wanted you to get that idea. I may comment that out just so that I don't have to type in something every single time I run it. And if you didn't type it in, that's fine. The real point was to just alert you to it. All right, global variables. Global variables are variables that are accessible to all the code in the file. And in fact, any file that imports your file. Now these variables are kind of global already. If I do this, name is equal to Bob, and then down in here I define a function, define F1, and it prints out name equals, comma, name, and then I define another function, print name equals, comma, name. And then down here in main or whatever, I call F1 and I call F2. It's going to print out Bob twice, right? Because name is defined. It's defined at what's called the global scope. It's not defined in here. If I took this and I moved it inside a function, like if I put it here, don't do that. I'm going to immediately undo it. Then this will work. It'll print out Bob, but this won't because name doesn't exist. So I'm going to push this back up here. But now that it's a global variable, can I change its value? Can I do this? Can I say name equals Joe, and then when we call F2, have it print out Joe rather than Bob? Nope, it still says Bob. And that's kind of weird. It's kind of weird. Why do I say that? Because this created a new variable called name, leaving this one alone. And that's just kind of weird because you can print that variable and it's going to print this one out. But if you have name is equal to Joe or something, it's creating a new variable that has scope only for that function. But you can tell it, no, that function really, excuse me, that variable, I want you to use a global one rather than create a new one. In which case you do this, global name. And that says, oh, name is something that's defined globally. It's defined outside of all the functions. And now, when it sets it equal to Joe, it is still set for Joe inside another function. Now, sometimes we use stuff that looks like a global variable, and it kind of is. I know I haven't used the turtle language hardly but once in this class. But if I did, I'm going to erase this immediately. So don't type it. But if I did t is equal to turtle.turtle, and then in here I said t.forward, 100 pixels, and down here I made it go in a circle or something, right? 50 radius, whatever. So that works. It goes ahead and goes forward 100 pixels. It goes ahead and makes a circle. It sends the turtle doing all over the place because it's not creating a new variable called t. It's using the existing global variable called t. So I don't have to do global space t in order to get that to work because I'm not creating a new one down here. Now let's get rid of that. So if you want a function that can change the value of a global variable, you have to define it as being global in the function in which you are. So let's just add a comment to that effect. Tells this function to use the global variable. And I'm going to put a comment here. This is a global variable because it is defined outside of all the functions. And the way somebody structured the code, and now I don't remember exactly how they had structured it, made me think of this. They had listed some variables outside of any function, and it made me think of that. That's why I wanted to talk about it. So global variables are a way to create variables that can be shared amongst multiple functions. They can even be used outside of the code. If I go to and make another file, now I called this lecture O with a space in it, which is kind of stupid. I kind of need to, I'm going to save it with this lecture O without a space so that I can import it easily. So I'm creating a new file. I'm creating a new file, and I'm going to do import lecture O. And then I'm going to print, come on, lecture O dot name. I'm going to save this in the same directory as my original file. I'm going to call this lecture O2 just to differentiate it. Okay, now when I run it, it's going to run everything that's already in my original lecture 0. Why? Because it didn't do that __ main trick. So it's going to come down here and it's going to run F1 and F2 just as soon as I didn't do the import statement, even before I print the name out. I'm going to prove that point by putting a print statement up here after import. And then I'm going to put a print statement before the import that says before import. Trace back. No module named lecture 0. Remind me, do I put quotes around it?
Lecture O.
Yeah, not 0. Derp. Okay, thank you. All right. No module named lecture O. You would think that I would remember this. We just did this earlier in the semester. For Pete's sake. All right, guys, so I did a rename of the file, and then it was pointed out to me that the problem was a case problem. I had an uppercase L in one place and a lowercase L in the other. No, anyway, so before the import, great. And then as soon as it did the import, it went ahead and ran the code inside the file. And then after the import, and then we actually printed out the name. So we were able to access the contents of that global variable even from another file. Now if we had done this, nah, that's enough. I think that I want to arrange the code for the other function though, so that it doesn't trigger automatically. So I'm going to load up lecture O2 the way I had it, and I'm going to do that if __ main stuff, and I'm going to define a main function here. Define main, and I'm going to push those guys over, and then down here, or maybe I won't even create it, a main for now. I'm going to go over here, and after the import is done, at the very least, it should not print out anything. But I need to import lecture O with the capital L. All right, so test is not defined. That's because I called it lecture O here, and I forgot to name the module. Change the module name to lecture O here. All right, so it did the import. This time it did not execute any code. And then it printed out the value of that global variable. If I wanted it to run main, great, I could do so, right? I could run lecture 0.main, lecture O.main, right? And now and only now will it actually do that other bit of business and change the name of it to Joe. So that's why I've been having you sometimes create your code inside a main method and then invoke it inside of another if statement. If underscore underscore two underscores name underscore underscore equals equals quote underscore underscore main underscore underscore end quote, call main, like that. So if I go back over here and I delete the call to main, and heck, I'm going to I'm going to comment out the printing of that name as well. Then when I do the import, it doesn't trigger any code. And that's what I want. You don't want code magically triggering just because it was imported into another one. So it's a good idea to always do this. Do you have to do it if I don't tell you to? No, you don't. And what I've seen people doing is defining main, and then rather than putting that if statement, they call main down there. Well, that's a real good step in the right direction. But if you're going to go that far, go ahead and stick it in the if statement as well if you can figure out how to do it. All right, so that's global variables. The takeaway is it's a variable that's accessible to all of the functions in that file and even outside that file. But if you're going to change it, you have to define it as being a global variable. You have to tell that function, oh, this is a global variable, so if I refer to it and I try to set a new value to it, I want it to change the global variable. Hope that makes sense. That makes sense. All the way, half and half? None at all? All right, good. Lecture M had a gap. Ian had a gap, as was pointed out to me over the weekend. I apologize for that, but you can find the missing code. It was shown on the screen, but you can also find it in the notes for that day. Okay. Let's go see where we are in our book, our online book, that is. And by the way, if you ever have a question over an assignment, do text me about it. And if it seems like a confusing enough point, then I can actually lecture about it and let everybody know about it, not just you. So it helps the whole class and not just yourself to ask me about it. I'm eager to get to lists. I don't even think we were done with 7, and I'm eager to get to lists. So I'm going to go to chapter 8. I better check to see what our homework is over chapter 7. Make sure that I'm not messing us up by skipping or by not finishing that chapter now. Go look. Network sure is going slowly today, at least in my opinion. So online chapter 4, online chapter 5, online chapter 8. Well, apparently I've done that in the past. Okay. Probably means I should have create some online homework for the other ones as well. But okay, we've talked about lists already. It's a sequence of values. Some languages call it an array, and I have mentioned before that there is a difference between a list and an array, except Python doesn't even support arrays. So this looks like an array, but it's not. The difference being that a list you can change. You can add items to the end of it. You can change its length. I mean, it's a dynamic structure. You can append things to the beginning, to the end. You can insert it in the middle. You can delete. You can't do those things with an array. Once you declare an array of length 4, it's stuck at that length until you create a new array and maybe copy those values in it. So I'm not going to use the word array except by accident from here on out because these are lists. A list can contain a list, which is bizarre, but it works. I don't want to spend too much time about it because I don't particularly like it, but you got to see it because a lot of other programmers are going to use that tactic. So I'm going to go down here in my main, and I'm going to declare a list that has a list in it. Well, firstly, I'm just going to declare a list. It's not going to be a real complicated one. It's just going to have my favorite numbers, 8, 6, 7, 5. That's enough, and not points. Now I'm going to write a for loop that prints them out. And I'm not going to use an index-based loop, so I'm not going to use a range statement. I'm going to use a for each loop, a for value in list loop. So for value in L, I'm going to print that value out. Now, if you've been skipping typing, this would be a real good place to pick it back up. Maybe I'll cut this and put it down here at the bottom to make it real easy to follow. Pretend this is a new file. All right, so it's going to print 1 per line, 8, 6, 7, and 5. All right, great. But what if one of these elements was a list? What if I took that 5 and I defined a list inside a list, like this? And I put some numbers here, I don't know, 1, 2, 3, 4, like that. Then when it prints it out, it's going to print an 8 on one line, it's going to print a 6, it's going to print a 7, and then it's going to print a 1 and a 2 and a 3 and a 4. No, it's going to print all of this on one line because this is one element of that list, right? An element can be a number, it can be a string, it can be a list. So there it goes. Now, why would you want to do that? Well, because you could make a list that had like a person's name as the first element and then a list of their test scores as the second element. Something like this. You know, grade is equal to, you know, or grades is equal to, and I'm going to put a brace there to define my list, and this is Sam's grade, so I'm going to put Sam in quotes if I can type. And then in another list, inside the list, I'm going to put some grades. He made a 90, then his fortunes picked up, he made an 8, well, went down, he made an 85, but then he made 100, and he made another 100, right? So we could print that out, and if we print it one item per line, the first line is going to be Sam. The second item is going to be a list that we can average. So name is equal to grades subscript 0, and then scores is equal to grades subscript 1, and then we could calculate the sum and the average and all that stuff. You know, total is equal to the sum of the scores. The average is equal to the total divided by LEN of the scores, right? And so on. So we have two pieces of data here. Now this piece of data happens to be, you know, comprised of other pieces of data. But we only have two list elements here. And it's a list inside a list. Am I going to do that a lot in this class? Probably won't show it again. But I want you to remember it. I want you to tuck it away in your head. And you could check to see if the type of an element is a list, and you could treat it differently. Because you can determine whether something is a list by calling the type function, like this. I'm going to create a silly list here. It's only going to have 3 things in it. But if I do type of G, it tells me that it's a list. So I could do if the type of G is equal to list, then print yay, whatever. And it did print yay because that actually was a list. So while we were iterating through the list, if value was a list, we could do something special. We could iterate through that sublist. All right. I think a list inside of a list is about enough, but let's go and look. They did talk about that right there. That's called a nested list. You can make an empty list. An empty list is just when you use square braces with nothing in between. And you can, of course, assign a list value to lists to variables, which is what we've been doing all along. Here's 3 kinds of cheeses. Here's 2 numbers. This is empty. And that slicing we were doing on strings works just as well on lists. Lists are mutable, meaning that they can be changed. If you recall, maybe you recall, if you do something like this, S is equal to Bob, and then you try to change one of those elements. I don't want it to be Bob anymore. I want it to be Rob. So I change the first element to an R. Well, no, I don't. That's an error. It won't let me do that because strings are immutable. Immutable meaning they cannot be mutated. They cannot be changed. However, lists are fine to change. You can change a list all you want. I'm going to comment this stuff out and just add a comment. This does not work, or this is an error because strings cannot be changed. They are immutable. But let's make a list that can be changed, or let's make a list and we will see that it can be changed. Foods is equal to, ice cream, kiwi fruit, kale. We're getting just increasingly vegan as we go along here. Alrighty. Now one of these is not like the other, so maybe we better change. Maybe we hate kale and we want to substitute something else. I want pizza. So if this is index value 0, then what's the index value for the entry that says kale? 2, right? Okay. So we're going to say foods subscript 2 is equal to pizza. And then if I print out foods, it's going to say ice cream, kiwi, and pizza. It has actually changed it, whereas that did not work with strings. In a few languages, you can change strings like that. In C, C++, you can. In Java, in this language, you cannot. All right, so it took our kale out and replaced it with pizza. A very common thing to do is to create an empty list and then start appending numbers to it, or start appending values to it. Let the user enter some data, right? We ask them for data, and then each piece of data they type in, we add to the list so that we can do something later, right? A classic example being test scores, right? We get a series of test scores, or temperatures so that we can calculate the average temperature or something like that. So the first thing I'm going to do is I'm going to illustrate just making a list that is a series of numbers, right, from 1 to 10. Why don't I push this up there? I don't know why I have that down there. All right. So I need to create an empty list first so that I can start adding data to it. And there's nothing magical about capital L. It's just that that's how I name a lot of my lists, so that if you're looking at example code and you see capital L, you know that your professor was creating a list. Okay. So I'm going to use a for range statement to count from 1 to 10. And I'm just going to append those numbers to that empty list, and then when I print my list out, I'm going to see 10 numbers. Do I need to slow down, or is anybody seeing syntax errors that they would really like me to come look at? Alrighty. Oh, that reminds me, temporary side diversion. If you cannot figure out an error, look on the line above it. So for example, if I did this, L is equal, and then I made a list with inside a list, so 1 comma and then another square brace, 2 comma 3 comma 4 in square brace. It looks great, sure. And then I print L equals end quote L. I'm probably going to wind up commenting that out. And then I try to run it. It's going to show me, well, especially if I took that blank line out between them. Oh, I did not mean to close you. it's going to show me this as being the line with the error, the print statement. And you can go nuts staring at that print statement wondering what in the heck is wrong. The problem is on the line above it. And in this example, I think they had a print statement. But if your line above it does not contain the same number of opening parentheses and closing parentheses, then it'll be a problem. We have 2 opening braces, so we need 2 closing braces for it to be good code, like that. Just like if it was a print statement and you were printing out the integer value of something like that, you know, and you didn't have enough closed parentheses, well, here you have 2 opening parentheses, so you have to have 2 closing parentheses. If you don't, then the next line is going to show up as being a syntax error, but that is really the problem. And that is why some languages insist upon you putting a semicolon after every line. That way it knows, oh, well, the programmer thought that that was the end of the code. And it'll go ahead and highlight that line, you know, say that there was something wrong, because it knows it was supposed to end there. All right, let's delete that stuff, and I want to do the loop that I was about to talk about that will add numbers to that empty list. Well, let's just add something to it even outside of a loop. I'm going to add a number to it, 999. And then I'm going to print my list out. So when we see it, it's going to be a list with 1 element in it equal to 999. And if I called append 888 or whatever, then we would see 2 elements in it. L.append 888. So now we're going to see 999, 888 being in our list. So that's what append does. Very common operation, because how many times do we already have all the data pre-programmed into our code? Very rarely, right? I mean, you know, if you're reading in census data or whatever, that census data is not going to be, you know, written into the source code. It's going to be, you know, read from a file and appended to a list. Or we're going to ask the user for some test answers, you know, and we're going to create a list full of test answers, or, you know, whatever. So appending, we're going to be doing all the time. So let's make some code that will append the numbers 1 to 10 to that little list that we've made. So for x in range, I want to start it at 1. And since I wanted to stop at 10, what's its upper limit going to be? 11. Yep. And I want it to skip by 1s. Well, I can leave that part off. If you're only skipping by 1s, you can leave that off. And then I'm going to say L.append the value of x to it. So it's going to append 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's not going to replace these values. They're already on the list, and we're only adding on to it. Just like if we have a piece of paper and we write the top 2 lines as being 999, 888, and then I give you that piece of paper and I tell you to write the numbers 1 to 10 on it, it's still going to have 999, 888 on it, unless you grab an eraser. And there they are. 999, 888, and then followed by all the numbers. We could be asking the user for numbers, or we could be reading from a file. Rather than generating a range of numbers like that. All right, let's get the first 4 values out of that list and put them in a new list. We got to use slicing in that case. So I'm going to call this one NL for new list is equal to list, and I'm going to use slicing it. If you remember slicing, it uses square braces. You don't have to put all that space in there. Separated by a colon, and you put the starting number there, and you put 1 past the ending number there. So if I want to go out 4 places, I'm going to put a 0 there, and I'm going to put 4 there. The easy way for me to think of it is I want to start at position 0, and I want 4 elements, so 4 minus 0 is a length of 4. So I'm pretty sure this is going to be right. You would think. And I will explain real soon why it's actually 4. It's just the weirdness of slicing. Okay, so here we go. Why does that actually give us 4 rather than 3? Because it starts at 0 and it goes up to but not including position 4. So that's 0, 1, 2, 3. That makes sense? So what if we wanted to start at, what if we wanted to get just these 3 values? What is our starting value going to be? What's our starting index? Y'all can count. That's index 0. That's index what?
1.
And so this is index what? So we're going to start at 2, and what is the index value of 1 past the end of the list, which is that one? What is that one's index value? Is that 5? All right, 0, 1, 2, 3, 4, 5. Okay, cool. So instead of saying 1 to 4, I'm going to say it's 2 to 5. Now, eyeballing it in my head, I can see that the difference between 5 and 2 is 3. So it's going to start at position 2 and be 3 long. I can predict that just by seeing the slice. So when it runs, it's going to be 3 elements. Let me close this and run it again. Right. So we started at position 3. Well, index value 2, and we got 3 values out. Maybe I'll put that other one in there. I deleted it, but so 0, 4. What did this do? Elements 0, 1, 2, and 3. And this one is elements 2, 3, and 4. And I guess I'll make a comment that this is slicing examples. If you leave off the first number, it starts automatically at 0. And I always think big whoop. Why? You know, I only saved 1 character of typing by that. But the cool one is if you leave off the last one. If you leave off the last one, it goes all the way to the end. So if I do this, I've already got an NL. I'm just going to call it a new list, XL for new list. I don't know why. Starting at index value 5, but going to the end of the list. This is going to be elements 5 through the end. So now I'm going to print those. Print XL. And so if this printed 1, 2, 3, the rest of the elements are 4, 5, 6, 7, 8, 9, and 10. Like that. So if you don't have a value between the square braces, it returns an element. If you do have a value between, if you do have a colon between the braces, then it actually returns a list. Let me see if I can show you what I mean. If I just print out the first element of XL, like this, as opposed to the whole thing, then when I run it, see, when I just printed out XL, it was an entire list. Slicing returns you a list. But indexing, which is when you don't put the colon inside the square brackets, doesn't return a list. It instead returns the element itself. So you have to kind of be careful of that. Just remember that it's different syntax. You want to get a specific piece of the list, just to process one piece of it, then you use square braces with no colon. Excuse me, Mr. Phone. If you wanted a sublist, then you use the square braces with a colon, and that gives you a slice. So one element of the list. So when you're talking about lists, you can access the elements starting at 0, going out to n-1, where n is the length of the list. If I called len list, it would tell me that the length of the list is 12. So that means that that guy's position is 11. We can count them out to make sure. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the last one you can get to is length minus 1. N minus 1, where n is equal to the length of the list. Python gave us that easier way of doing it. You just call minus 1. List subscript minus 1, and it'll get you that one. And list subscript minus 2 will get you that. List subscript 3 will get you that. And no other language I've ever seen does that, but it's really cool. So as you're iterating through a list, if you use a range statement and use indexes to access the list, you can actually change the values. When I did my printing of the list like this, oh, I guess I never did print it. Yeah, I did, right here. If I had tried to change the values of the list as I did this, the original list would be unmodified. And I can kind of show you what I mean. I'm going to print out this Excel list, but then I'm going to be trying to change the values as I go. So for value in Excel, print the value, and then set the value equal to 0. And now underneath it, I'm going to print Excel again because I want to see what happened to the list as a whole. Did we set every element to 0? Let's find out. No. It still contains the original data. Why? Because this is just a copy of the elements in the list. I would have to use an index-based, a range-based for loop in order to actually change the values. Like this. For index, I'm just going to shorten it to I. For I in range up to the len of the list, now I have to have 2 colons because I had, 2 closed parentheses because I have 2 open parentheses. Let's print that element out. Print Excel subscripts I. I typed a 0, then I backspaced over it. That was my mistake. Right, so print Excel subscript I, and then let's set Excel subscript I equal to 0. Then I'm going to print out the whole list again. Print Excel. And I will see that the values have all been zeroed out now. So that did, in fact, nuke the contents of the list. Because by using indexing, I'm actually getting a hold of the list itself. This just gives me copies. Like I gave you a book, but I photocopied each page of the book for you to print out. Here, I'm actually giving you the book and letting you do whatever you want to. So if you're going to scribble on every page of the book, fine. That book has been changed. Here, if you scribbled on that page of the book, you're just scribbling on a photocopy sheet of that page. It doesn't change the original book. So I guess if I was going to make comments, the for value loop does not allow us to change the elements of the list. So the above code doesn't, this is too much typing, doesn't modify the list elements. And then I'm going to add a comment to this one that indicates what happened. The for range loop lets us change the elements of the list by their index. So the above code does modify the list elements. So why is that important? Well, sometimes you do want to change the values of the list. The next piece of code shown on the website shows doubling every number in the list. And if we wanted to double every number in the list, we could not use a for value loop like that. And by the way, there's nothing magical about that word value. You could say for Fred in Excel, print Fred. Just like there's nothing magical about the variable named I. You could, call that Birdie. For Birdie in range, whatever, print Excel subscript Birdie. Variables are just supposed to be names for us to understand what they mean. The computer doesn't care what variable names we mean, what variable names we use. So you don't have to do for value in. It just helps me remember what kind of loop it is if I do that. So what if we did want to multiply every value in list? Instead of setting it to 0, let's multiply all the values by 100. So I'm going to, no, I better not change this because I've already commented what it's supposed to be doing, right? So I am going to type it in again. I could have just copy pasted it. So for I, short for index, in range, parentheses, len, parentheses, XL, close parent, colon. I better use a different list though because we've already set all the items to 0. Why don't we use our original list, L? And we're going to say that L subscript I times equals 100. We're going to multiply every element in that list by 100. And let's print it out beforehand and afterhand, if afterhand makes sense. Let's print out L here in front of it, and then print out L after our loop. Print loop, print L there. Print L there. And we will see that every value in that list has been increased by multiplying it by 100. So we were able to make that change because we were using an index-based range loop. If we used a for-value loop, then even though we were multiplying the values by 100, it wouldn't work. So I really want you to know both ways of iterating through a loop. Let me make a comment to that effect. So 3 quotes. I really want you to memorize both ways of iterating a list, or traversing a list is how the fundamentals book called it. Iterating through a list. The first way, the value. For value in L, whatever your list variable is called, print value. Please remember that one. So this is the for value way. And then the for range way, or the for index way. For index in L, or you could use, nope. For index in range, parentheses len, parentheses L. So this is a for range loop, an index-based loop. Then print the list at subscript index. Just memorize both those boys. You'll see them on an exam, maybe in a quiz.
Not this exam, right?
No, not the. Some people have already taken it, so it'd be real mean of me to be throwing new stuff onto the exam. You're correct. Next exam. Quote, quote, quote in that comment. I certainly want you to remember how to append to a list. You use l.append. Let me push this up to the top of the screen. l.append appends x to the end of the list. What if you want to insert something into the beginning of the list? I think it's add. L.add into position 0. I want to insert the number 98765. And I may have that wrong. Yeah, list has no attribute. So what are the attributes of the list? Since I didn't remember what the list attributes are, I'm going to create a list, and then I'm going to type dir subscript L, and it will tell me all of the methods that the list has. All right, somebody remind me, what's the way that you insert into the middle of the list? Oh, well, what do you know? It's insert. Okay. So instead of l.add, it's l.insert. this will add this number into the beginning of the list. I might have the order of the parameters confused. Nope, there it is. So let me go and add that to my little list of things that I want to memorize. L.insert x comma y inserts x into position y. So if I did insert, nope, that's backwards. Inserts y into position x. So if I wanted my new number to be the second element of the list, I wouldn't do that. I'm going to insert a different value, a -1, into the second element of the list. So now when I print it out, I'll see that the first element is that, and the second element is that. And that's what we see. What if you want to remove an element from your list? There's two ways of removing. You can delete by index value, or you can delete based on the value of the element. And those are two different things, right? If I have a list of 7 elements, then I could have a list at index 0, or I could have the value of that element. I'm not seeing the one that I think I'm looking for. Yeah, there it is. That's the one that I'm going to use to delete one of the elements of the list. I'm going to delete this -999 from my list. Excuse me, I'm going to remove it. Delete is a very specific term. So L.remove -99999. And now if I print the list again, I will see that that element has now been removed from the list. Yep. No longer there. My -999 is gone. What if I want to delete something by its index number rather than its value? So I'm going to put a comment here that this is removed by value. And then I'm going to use another one, which is the delete function, the delete keyword. Delete L subscript 0. That's delete by index. That will delete the first element of the list. Now, can you mix and match these somehow? Could you use L.remove to delete something by index? Yeah, you could. I almost don't want to type it. Here's what it would look like to use .remove to delete something by index. L.remove, parentheses, L subscript 0. And I'm going to delete that. It is that ugly, right? Why is it ugly? Well, because we're specifying the list element twice. It's much easier just to be able to do that, right? So let's add those to our comments, and we're going to be about done for today. So L.remove x removes the element at index x, or position x, whereas delete L subs. No. That's not by index. Deletes the value x from the list, which is not the index. And then delete L subscript x deletes the element at index, or at subscript x. And I'm going to change that word deletes to remove because that matches the function name. Alrighty. How do we create an empty list? I've already illustrated that, but I want to put that in this big comment, this mega comment at the end of the code. If I wanted to make an empty list, L equals, and then how do I define my empty list?
Square bracket?
Yep, square brackets. Square brackets. There are more obviously, like when I did this and I created a new list and then I typed in dir subscript L, we saw others, contains, and I've kind of covered that one before, but I want to cover it again just to bash it into our head again. And then there's, that's just about time to stop. Let's go ahead and stop here.